From a group of 5 seniors, 4 juniors, 7 sophomores, and 4 freshmen, how many different committees of 5 can be chosen if there must be at least one of each grade level? Now, since you're dealing with groups of people, you want to use combinations as opposed to permutations. Combinations is where the order does not make a difference. So if I pick a group of 3 people, say it's Tom, Joe, and Brady, okay, it does not matter if I pick Tom, then Joe, then Brady, or if I pick Joe, then Tom, then Brady, or Brady, then Tom, then Joe. It doesn't matter the order. So to take out the repeats, I'm going to use combinations. So that's what I have here, and I'm going to use this notation as you see in this drawing. So you first need to figure out how many or what different possibilities we have. So we need, it says, committees of 5 with at least one from each grade level. So we have freshmen, sophomores, juniors, and seniors. We have 4 different groups. So here's the possibilities. We could have 2 seniors, then 1 of each of the other classes. We could have 2 juniors and then 1 of the others. We could have 2 sophomores and then 1 of the others, or we could have 2 freshmen and 1 of the others. So we have these 4 possible scenarios right here, and we need to figure out for each one how many possibilities are there. So the first one, we have 5 seniors to choose from, and we're choosing 2 at a time. The order does not make a difference, so we're using combinations. So it's going to be 5 choose 2, as you see here. This is that notation. And then we have 4 juniors picking 1 at a time, so it's going to be 4 choose 1. 7 picking 1 at a time, it's going to be 7 choose 1. And then 4 freshmen choosing 1 at a time, so it's going to be 4 choose 1. So this notation, the 5, then the C, then the 2, what that means is you're going to have 5 factorial over, it's going to be 2 factorial, and then also I'm going to take 5 minus 2 and subtract those. I'm going to get 3 and then factorial. So when I do that, I'm going to have this, where it's going to be 5 times 4 times 3 times 2 times 1, then 2 times 1, and then times 3 times 2 times 1. And now here things can cancel out, so the 3, the 2's, and the 1's will cancel out there. Okay, I'm left with a 20 over 2, which is going to equal 10. So notice that's how I got this number right here. I got the 10. And then 4 choose 1 would equal 4 factorial over then the 1 factorial, and then 4 minus 1 gives me 3 factorial. That's how I set that up. So here you see 4 times 3 times 2 times 1 over 3 times 2 times 1. So things will cancel, and I'm left with just simply a 4, because this, and this will cancel. So that's where I get the 4 from right here. So if it's anything choose 1, so like 4 choose 1, it's just going to be whatever that first number is, so 4. 7 choose 1, that's going to be 7. 4 choose 1 is going to be 4. Here for the next example we see 5 choose 1 is going to be 5. So that's going to be the pattern. Okay, so we do the same thing for the other possibilities. So for the second one we have 5 choose 1, and then we have 4 juniors, we're picking 2 at a time, so it's going to be 4 choose 2, and then 7 choose 1, because we have 7 sophomores choosing 1 at a time, and then 4 choose 1, it's going to give me 4 C1 right there. So we have our next one, it's going to be 5, and then 4 choose 2. I can go through this process like I did down here at the bottom, and we're going to get 6, and then 7 choose 1 is 7, 4 choose 1 is 4, and then we multiply all those together. We get 840. The first one, we forgot to say, we multiply those together, we're going to get 1,120. We repeat this process for all of them, add all the possibilities together. Once we do that, we're going to get 4,480 as your final answer.